Hello everyone, welcome to this video. This video is about producing a random variable, and I have here different approaches: inverse transform method, relationship, Box-Muller method, and multivariate normal distribution. First method that I want to mention is inverse method. In this method, we have a distribution function of our variable, which is x, and we can calculate its inverse function. And so we can define our generating algorithm all as first step is generating this random variable. U should be only a random variable in this interval, and so we can put x equal to f minus in u, and we can return x, and x will be our random variable with our desired distribution. Actually, this method is really easy and simple to calculate, and the only thing that you need to know is information about distribution function. I have here an example, and it is exponential distribution, and it is the distribution function of our variable x, and so we can calculate inverse function, which will be this relationship, and we can define our algorithm like that first step will be producing random variable in this interval, and so we can put x equal to this equation and return x, and x will be our random variable with exponential distribution. The second method that I want to mention here is convolution relationship, and I have here some comments which you can read later, and you can easily pause the video and read these comments. But I want to explain about this equation. The first one is if we want to calculate x as a random variable with Bernoulli distribution with this mean and covariance, and we only need to produce random variable u in interval 0 to 1, and we can put x equal to this relationship as and with this equation we can calculate our random variable with Bernoulli distribution. And if we want x with Bernoulli distribution but with mean n, we need to produce n identical independent distributed variable like uk in interval 0 to 1, and we can put x equal to this equation, and so we can produce x with this wished distribution. And with this distribution, we only need to produce these two distribution u, and use this equation. And the last one is same. We only need to produce n uk. Another method which I love is Box-Muller method, and in this method you need to have two value for u1 and u2, for example. These two should be independent and standard normal distributed variable, and so with these two equations we can produce x and y as a standard normal distributed variable, which are also independent. Only you have to be careful in calculating cosinus and sinus in your calculator, and you should pay attention to radian modulus. And if we want to produce y with normal distributed with mean mu and covariance sigma 2, sorry, you need to produce first x as a standard normal distributed variable and use this easy equation. I like actually multivariate normal distribution, and in this kind of distribution you have a vector, and so you have to pay attention to a covariance function, which will be a matrix and not a single value or a vector. To produce x, which is a vector which n component, you have to produce first of all n z1 to zn independent identical distributed standard normal distributed variable, and you need a decomposition of a matrix sigma, and you can use a Cholesky decomposition method, which A should be a lower triangular matrix. And so in this method, after the composition of sigma, you need to use this relationship, this equation, which will be x equal to mu plus a in z. And with this equation, you can produce your random variable x with distribution normal, standard normal distribution with this mean and covariance function. I hope you find this video useful, and so if you like this video, please give it a like, and if you like, please subscribe my channel. Thank you. Bye.